Hello everyone, today we will talk about light waves or luminous waves and color. Did you know that light is just not white? It is made up of all the colors of the rainbow. But how does it work? Why do we see colors and what do light waves have to do with it? By the end of this video, you will understand how light creates a world of colors around us.
But what is light wave? Light is a type of energy that travels in waves, similar to the ripples you see on the surface of a pond or the waves in the ocean. But light waves are much faster. They travel at the speed of light, which is about 300,000 km per second in a vacuum. The distance between two peaks of a wave is called the wavelength. The color of light depends on this wavelength. Short waves with small distances between peaks corresponds to color like blue or violet, and long waves with larger distances between peaks corresponds to colors like red or orange. Light waves are part of a much larger family called the electromagnetic spectrum, which includes not just visible light, but also invisible forms of light like radio waves, X-rays, and microwaves. However, our eyes can only detect a small part of the spectrum, the visible light spectrum, between 400 nanometers and 800 nanometers.
But how do color and light work? When light touches an object, three things can happen. First, reflection. Some of the light bounces off the object, and this is the color we see. Second, absorption. The object absorbs the rest of the light, turning it into heat. And third, transmission. Some light passes through the object like through clear glass. Let's look at some examples. A red apple reflects red light and absorbs all the other colors. A green leaf reflects green light and absorbs the rest. And a transparent window lets most light pass through it. In reality, many objects do all three at the same time. For instance, tinted glass reflects and absorbs some colors, while letting others pass through. This ability of objects to reflect, absorb, and transmit light depends on their material and surface properties. Smooth surfaces, like mirror, reflect almost all the light, while rough surfaces scatter it in all directions.
Now, I'm going to talk to you about addition and subtraction. Colors works differently depending on whether we're talking about light or pigments, like paint. Firstly, you have additive color mixing with the example of light. When you mix red, green and blue light, you will get white light. This is the principle behind screens on phones, TVs and computers, which use these three colors to create millions of others. Then you have the subtractive color mixing with pigments. When you mix red, yellow and blue paints, you will get black. Why? This happens because each pigment absorbs or subtracts certain wavelengths of light and reflects others. For example, a yellow pigment absorbs blue light, but reflects red light and green light, making it look yellow.
Why is the sky blue and sunset red? The color of the sky depends on how sunlight interacts with the Earth's atmosphere. Why is the sky blue? Sunlight may look white, but it's made up of all colors. When sunlight enters the atmosphere, it collides with tiny particles of air. Short wavelengths, like blue, scatter in all directions. This scattering is why the sky appears blue during the day. Why are sunsets red and orange? At sunset, sunlight travels longer distance through the atmosphere. Most of the blue light gets scattered away, leaving the longer wavelength like red and orange to reach our eyes. This creates the warm, beautiful colors of the sunset. Sometimes, particles like dust or pollution can enhance this effect, making sunset even redder.
In conclusion, light is more than what we see. It's a wave carrying energy, and its color depends on the wavelength. The way light interacts with objects through reflection, absorption, and transmission creates the beautiful color we see every day. And it even explains natural wonders like blue skies and red sunsets. Thank you for watching this video, and I hope you'll never look at light and color